so happy. So good. Okay, on to the problems. Let me show you what I did since the last time I showed you anything about the slider. In the last live stream I completed mechanical assembly, but not the electrical assembly, because I wanted to do it on my own time and don't rush it. And I think that was the right call, because I found a bunch of things I had to fix and also was able to do a lot of testing. So, but now for mechanical changes here in the 3D file. Let's go by the list. So this lid has changed again. You can see before, after. Made it a bit more spacious and added a fourth plug here, which is a USB-C output, which is purely for power. The reason is I have these HDMI wireless transmitters and they use USB power. So I was trying it out a bunch here, filming a bunch of things with it. And I noticed it is really annoying to just have to look at the back here at the camera all the time and crouch down to see while it is moving if the framing is correct. So I needed to add the transmitter. The transmitter needed power, and power was available from USB. So I added a USB. Was really not that bad. It was like 2 revisions of printing, a little bit of PCB change. But now we have a USB out and you can power anything that gets 5 volts from it. Pretty nice. The focus unit has changed, mainly in here. You can see there was an extra screw here, which I had to remove because it was rubbing against the lens during filming. And yeah, so now it is a bit less stable, but still stable enough without the third screw. So that's fine. So the lid up here had a change. You see the middle part got a bit bigger because now I have to fiddle the ribbon cable, the big ribbon cable, through this hole in the middle, just so it can bend upwards a bit more. I gave it a bit more space here, which is fine. It does not interfere with any rotating parts, so that's okay. This ring has changed. Look at the difference. There was There was a little like a mistake in there where something has slipped somewhere in the design, I don't know. But basically the optical end stop was out of line from the rotation, so it would crash into the end stop fin, which had to pass the laser beam, or the LED beam probably. And it was like not a line that would crash into the side, so I had to change that a bit. Same thing here. This needed to be a bit taller to properly reach the LED. So the table feet, they had to change because they were too narrow, and when I panned this one out and this heavy back was out of center, it would just tip. So new table feet, no tipping. And now this here. There are a few changes here. One thing is I added a ridge for the lid to rest on. I have not installed it yet because it's not a major change, but basically if you grab it by the end piece here, I could feel the lid flexing and I did not like it. It felt like it was about to break, and if you grab it a little bit more secure, it would maybe crack. So these fins are there for support of the lid. Then down here you can see these holes have changed. I have removed this little standoff because it did not print properly, and 3 of these mounting holes are good enough. Yeah. Yeah, these are the mechanical changes. Good. The rig works as designed for the most part. I still intend to fix it to a certain degree to get to version 1.0, but it's getting really close. Yeah. So obviously everything moves and works properly. The moves are if you go too fast, they are not that smooth. So you definitely see some jankiness, which I will get into later. Focus mode works pretty good. as long as you always focus in one direction. So you start off far away and you get closer and closer and closer, and then it's good. So still some work here, but the motor is strong enough, the gear is engaging properly, and everything else in here works perfectly. So I suspect it's more like the setup of the camera. Focus pin and trigger pin, this was some work. But basically now I have defined inside Fluid_NC the focus pin and the trigger pin as a so-called user output, which is a digital pin, just like a GPIO pin from microcontroller you can turn on and off, and with a bit of circuitry after it, with some optocouplers and whatnot. This is basically a switch to engage your shutter button on your camera. So if you half press your shutter button, the camera will focus, and the same is with the focus pin. So if I pull this pin high, the camera will focus. And the same for the trigger pin. If I pull the trigger pin high, the recording will start. And I have added this to my G-code generator. So at the beginning of like a move sequence, the recording will start and it will end the same. So no more pressing record or anything, which is really good. Took a while to get it started. Almost ordered a new PCB until I noticed I had done something wrong in the wiring. Yeah, so no, you have like a 3.5mm cable to 2.5mm TRS cable. Plug it into the camera. You have to activate a camera setting that it will listen to such a remote control basically, and then you are good to go. It's the same as like an external mechanical shutter button. Yeah, good. Power to the camera works great. This is the one thing that just worked out of the box flawlessly. I have like a dummy battery I put into the camera and connected to the 8.4 volts I'm getting out of here. Set it and forget it. It's perfect. USB connection is I had some problems, but I don't think it's part of the setup here, because if I have it like to a universal G-code sender or to Fluid_NC over USB, no problem at all. No disconnections, no hiccups, nothing. So removing the slip rings was definitely the right choice. And to be honest, I don't miss them. Like I have done a couple of little shoots and moves and try it out. I never missed having a full rotation. It just was not a real requirement to begin with, basically. So hardware is completed-ish right now. So mechanics will not change. This is to stay the same. This is fine. What will change, what has to change, is a little bit of wiring because of a problem I will explain shortly. So the plugin I'm writing for Blender called Mocolotive, which is my very funny name for my automation software. Basically, there's a plugin for VS Code which lets you write add-ons for Blender and integrate them and debug them, and it's really great to use. Yeah, it's a really good plugin. I've chosen Blender because it's open source and modifiable. I know a little bit of Blender, 0.001% of Blender, like panning around, adding cameras, making like keyframe animations, a little bit. I know nothing about modeling, textures, rendering, or like all the software is intended to, but basically what I want to do is define camera paths in Blender for the virtual camera and transfer them to the real rigs I have here. And this includes the PanTiltSlider and the rotary table right now. But in the future, when I want to build like robot arms or more sophisticated rigs, it will be added there too. So right now my direction to go is have everything in Blender, because the creation of animations and motion paths is really comfortable in there and better tested and implemented than anything I could ever do. So here, this is just my boring old Python code. I will publish this to GitLab so you can have a look there yourself. But basically from here, you start Blender. It asks you which version, 4.2 I'm currently in. Then it does some magic. Too many screens. Okay. Okay, so I have like a Blender file prepared here, and this is my little animation. And if we go through the animation here, you can see this funny looking thing here. That's the camera, and I have animated it along the slider path to go here. This little ball thingy here, that's the focus point of the camera, so it's always looking at that, and when you move the focus point around, the camera will pan and tilt to get there. This contraption down here is my rotating plate. It's not animated right now, but it has a restriction on it, so it will always face the camera. So you see. And you can do some really fun moves with that, because it is rotating and always keeping like your line of sight, let's say, and the camera slides there. You can get really close in there while the background does like a parallax thing. It's really fun to play around with. So the plugin itself, that's the thing here on the right side. That's what I did. I should do this with an example. Okay. Okay, we plug this in, and this works. I have tested this with like a 5-meter USB extension, and it still works. So yeah, pretty good. So we can now turn it. I have no camera in there. Does it matter? No. Let's turn it on. And now still it's pretty rigid, but you can see a little bit of jank. I hate these bearings. They're gonna get removed in the next version, but not this version. Okay, now I have like a serial port in here. It says COM8. I will map it to the camera, and then I can select Add Update Connection. Yeah, and there's the first problem. So permission denied. That's the CH340 or something serial to USB converter on this Arduino Uno, which is totally unreliable, really bad choice. It's gonna go in the next version, but not in this version, so we have to deal with it. And the way to deal with it is just reinstall and reinstall this driver. That's the driver. You install it and install it and install it over again. Then it will work again. So install successful. Okay. I don't know why it was permission denied. That the driver seems to unload itself from time to time. So same thing, update connection. So okay, see, while this button is blue, it's doing something, and now up here the connection has been added. So this pans, that's the name of the rig. You can define this name within fluid_nc config, and it will read it back in the beginning of setup. So it tells you I have connected to this device. So next thing is the COM port, COM8, then the object we have been connected to, and if you open this up a bit, it tells me it is connected. So you can add a bunch of connections here and manage them all and change them and so on. But if I select this one, you will now see the mapping. This means if I change the location of this camera here, like in the x-axis, it will be translated to the x-axis inside fluid_nc, which is the sliding back and forth. Then rotation around the x-axis is basically the tilt up and down, and rotation around the z-axis is this way here. which is the y-axis inside Gerbil. That's just how I have connected these drives to the driver and everything. And the focus motor is connected to the a-axis. I've checked trigger recording, and this is this. And yeah, the I think genius thing about is this setup and this connection mapping and all these settings are stored on the FluidNC controller itself. The FluidNC controller has a little bit of flash memory, and I have stored a ini file there, and you can read all this information here. So this little file is stored on the FluidNC controller, and when I connect, I check if there is such a file on the flash system. I read it, I parse it, and then I can fill in all my settings. So your configuration is stored on the device and not on like a configuration folder on your host. That's the one thing here. The other thing I think was a good idea here is in the past I used to write G-code streamers, which means if I program a move, I stream the G-codes like Universal G-code streamer or any other G-code streamer to the controller over serial, and I have to check the buffer that it does not overflow, it does not starve, and if the command has been parsed, I have to remove it from my queue, and it's a huge mess, very error prone and not that easy to do. I was pretty sick of it. What I did with this is I read the documentation and the documentation of FluidNC says it has for one local flash storage of maybe a couple megabytes, couple 100 kilobytes, it's all I need, and it can upload files via X-modem. X-modem is a really old protocol where you can upload files over serial basically. It's pretty slow, but the files are not that big, maybe a couple kilobytes if they are huge. And so what I do is I program my moves here in Blender, then I hit bake. What this does is it translates the keyframes in Blender to a G-code file and uploads this G-code file via X-modem to the controller, to all connected controllers. So if I have like 5 more connections here, each of them get their own G-code file depending on which source they are paired to. And when I want to replay the animation, I just tell every controller, load this file from your memory and execute it. So I don't have to deal with streaming, with buffers, with anything. It's when this works, the times this works, it works really good. The problem I have right now is that sometimes the connection becomes corrupted and I can no longer upload things. But this is just the software outside of this project basically. The project itself I want to finish is the slider right now, and this is close to being finished. So yeah, okay, let's do an animation. Okay, so I will use this pre-done animation here. I have no camera here and nothing, but what I want to do is hit bake. Now it does all those things, translates the keyframes to G-codes. So it goes to the first frame, it checks the location of all the objects and puts the location in the G-code. And then depending on your frame times or the time between frames, it adds a duration for the animation there. So you have like the duration of 1 frame to get from this position to the next position. So it takes like a little snapshot where it has to be every frame. This is smooth enough for animation, but you can go down to 10 FPS and it's still smooth. 10 FPS gives you 100 milliseconds per animation run, and that's plenty. You know, with acceleration, deceleration set inside the FluidNC controller, it's really smooth. And you see in the sample footage, it's from like just the movement here, it's perfect. It's really good. Right, we have hit bake. This means the file has been compiled and uploaded to the FluidNC controller. What we have to do now is hit home, because this guy doesn't know where he is. So send him home from here. That's what I meant earlier with like homing all the axes at once. Number 2. And the focus unit does not have to be homed because it does not have a home switch. I do this via the clutch on, like this friction clutch on the camera lenses. I just turn it in one direction for really long. That way I can be sure that the lens is all the way back, basically. Now you hear the sound. Yeah, maybe the microphone picked it up, but these bearings are horrible. I hate them. They have to go. Next version, they're out. I will use better bearings. Yeah, but for now we have to deal with them. So we are home now. Normally after homing in a CNC, it's like back at the end switches. But we are far away from the end switches right now. What I have done is I have written a little script that is executed on the controller after homing. So it tells me to go to this position on like the pan axis and the tilt. I have verified this with like a digital angle finder, basically. You can measure angles depending on the rotation of the device. And so this is horizontal. This is completely in line with this axis as far as I can measure. And now we are good to go. So we are at the first frame in the software and I hit move to position. So you can like put your cursor here anywhere on the timeline and then hit move to position, and it will move to that position where all the animations are right now. And this is again for all interfaces. So if I have like 5 more things connected here, they all move to this point in the animation. And that way I can check focus at this point, for example, or if I have to adjust it a little bit. But yeah, this is just a demo right here. So let's go back to the beginning, move to the position. And now if I hit play animation, it will tell the controller to execute the file we have uploaded earlier. And play. It gives always a little delay at the beginning, so I have something to cut out before moves and to give like the system time to settle. You know, if it has moved there and it's still shaking a little bit, it can settle down. But you see this movement is really smooth and pretty quiet if the move is slow. But yeah, so far so good. That's working really well. Moving out of frame here, barely. Yeah. Okay, so move is done. Recording would have stopped, and now I can tell him again, move to position. So he's coming home again, and I can start from the beginning. And what you can do now is like swap out your target or remove green screen or adjust camera settings to maybe do like a zoom in and do the same move again. And it's the same frame by frame. Play animation, off you go. Yeah. So happy. So good. Okay, on to the problems. This animation here, like the one we just played, is pretty fast in comparison. And when I do some slower moves, I noticed that this rig gets out of sync with like the rotary plate. And I have dug a bunch around on the Fluid NC forum and searched why, and the problem seems to be, go there, good. There's a counter inside Fluid NC to count the time between steps of the stepper motors. When I move really slow, the time between steps becomes longer than this counter can count. And what they have decided to do is, when the timer runs out, I'm going to do a step anyway. No matter if I have reached the time I wanted to reach, I'm going to do a step anyway. So there's really a minimum speed this imposes, which is like a totally fine decision. That's in normal machining, which this is intended to, this is not a problem. But in my special edge case, this becomes a problem. So what I have done, I have opened this up and increased the microstepping of the TMC drivers to 64 microsteps, which has gotten rid of most of the problem. So the, let's say, normal slow moves are fine now. But this is only one of the problems this rig has right now. Hardware problems. Hardware problems, where to begin? Okay, let me move this guy here. These bearings are crap, and the more I use them, the more I have learned to hate them. They are poorly manufactured. Then for some reason the manufacturer tried to coat it in something silver. I don't know what it is, but it comes off at some parts. It's not very precise, not even the holes are all like symmetrical or even the same diameter. The only other thing these bearings have is they are big and cheap, and that's why I use them for so long. But if you have, yeah, I will zoom in, then you can see this. You see? You can even hear it. So this whole thing moves by like, let's say 3 or 4 millimeters out here, which is crap for precision. It's just bad. Same with this here. You see how much this moves? So if you have like a big heavy rig and the weight shifts because of a move, it will make a zip. It's so bad. And also we have these belts here. They are under tension, and together with the wiggliness of these bearings, this makes like a little element that's prone to catching vibrations. So if you move fast and you're filming, well, then you can see this in the footage that the image goes pop, 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 pop. There's like a vibration happening here. So these are the two things. The third thing is this V-slot rail. You see during the moves, if they are a bit faster, it's vibration again. It's if you tighten them too much, you get like more friction and more abrasion on the wheels, which makes them like less precise over time. And if you don't tighten them all the way, you get the wiggliness again. So these will have to go as well. I want to experiment with like linear rails. I hope they are smooth enough. But other than that, I don't know yet. But these problems are not gonna be dealt with in this version because I wanna get finished. So version 1.0 will keep the crappy wiggly bearings and the crappy V-slot rails. And yeah, that's just version 1.0. If you drive slowly and don't do anything sudden, it's great, you don't see it. And if you don't zoom in too far, you don't see it as well. That's yeah, really enough. I hinted to this earlier, but this camera, the height of the camera is fixed. And I don't like this. I started this when I had a little tiny Canon 80D, and it was perfect for all this. Now I'm using cages on my cameras and want to do like 15mm rods underneath, and suddenly the camera is up here and all these angles are wrong. So I want to make this height adjustable in the next version. However this will look, I don't know. But this is something that's bothering me right now. Electronics. The electronics right now have a lot of crimp connections, and I hate crimp connections. They can be unreliable if you do them wrong. They are hard to get right. They are time consuming to do. You need special tools, you can get cheap special tools, but then you have bad cheap special tools. It's just not great. What I do like are IDC connectors, which are these for ribbon cables. You just slide the cable in, put it in a clamp or a vise and clamp it down, and you're done. And the other side is just like a double row pin header you can put on any PCB, really cheap, easy to solder. And that's what I want to do for the next version. I want to do a custom PCB. Maybe I will stick an ESP up there or solder it directly. because the ESP modules have their own problems, which I will get to in a second. But yeah, custom PCB is the next thing, because this CNC shield is not that great. You have seen the problems with the serial to USB driver, which is, yeah, I just hope the other drivers work better. And the new PCB, I want to like directly attach the TMC drivers with like still step stick modules, but just plug them in the PCB, and then I can have the UART connections there as well. Yeah, so much better than all this cabling and wiring going in there. Yeah, the TMCs, the ESPs, let me put a couple here. These little guys here, that's like the VMOS D1 Mini, like a smaller module. I used this on my rotary plate. And that's the big boy module you can get for $5 on Amazon, called the Vroom 32. And all of the designs, I don't know why, but they have crappy power supplies on them. They have like this tiny, probably linear regulator, maybe buckburst. And if you do something as compute intensive as FluidNC does during startup, when the capacitors are not charged of the power supply, it will go into a brownout and restart itself. And this is just, there's nothing connected. It's just this crappy module with USB and the computer. And its own power supply is not strong enough to support itself during boot. So you can get a better, like if you're lucky, these capacitors have like huge variations between them. If you get a better capacitor, it will hold the boot. Or if the Wi-Fi turns on a little bit later, it will boot. And if not, it will not boot and go into an infinite loop. I had to dig a lot for this. And the solution is to support the 3.3 volt pin of this board with a capacitor. That's all you have to do. And this capacitor will charge, it will keep the power up, and now it can boot properly. And yeah, a lot of people have stumbled upon this with other projects, but it's, come on. If you make a board, make the power supply big enough for it itself to survive. There's no periphery it has to power, it has to keep its own lights on. Yeah, so that would be something I would want to solve with a special PCB. Good, what else?